As both as player and developer, I love juice. But I'm not talking about orange juice, I'm talking about game juice. Juice in video games refers to the particles, camera shakes, explosions, sound effects, that intangible feel that make you say, man, this game feels amazing, giving you a hit of dopamine just by pressing a button. In this video, I want to build a reusable toolkit to implement all of those juice elements into my game in a clean, simple way. The problem is I already created several of these mechanics, but they are scattered all over the place, plus there are others I never even had the chance to implement. It's time to organize, design, build, and test the juice. I've given myself just 24 hours to pull this off, mainly because I've been procrastinating on it for a long time. This video will be a success if we manage to finish the component, add new effects, and leave it future-proof, modular like Legos. I never had Legos as a kid. Who said? Let's start with problem number 1, creating the Lego bucket. Think of it this way, each effect is a Lego brick. We need a nice bucket, not too dirty, to store them so we can pull them out when the time is right. You couldn't pull out a bucket of Legos on a date. Terrible idea. Well, maybe not, but we have a dilemma. How do we know which effects belong in here and which don't? This bucket will belong to the main character and hold its common effects, but we are going to be generous and share this bucket with other actors too. The goal is to identify shared general effects that multiple objects can use. For instance, when we pick up a coin, the character reacts by scaling up a bit, while the coin spawns a small particle. Both actors react to the exact same event using the exact same component. So let's go ahead and create the bucket, which is really just an actor component. Now we have to do something extremely difficult nowadays. Think. For version 1, I want to keep it simple. I only need 3 things. First, implement the base effects, configure the component, and the last one, keep it organized for the future. If we get these 3 right, we call this video a success. First problem, the bucket is completely empty. Time to start writing code. One golden rule, our component should never know the actual game logic. It has no idea what a coin is. It only knows it needs to trigger the pickup event. I started by creating an enum, which is basically a shared list of name, pickup, impact, jump. This acts as a keys that our component reads to trigger the correct response. It's like a texting a friend asking for a small red Lego block. They hand you the exact block without having to rifle through the box one by one. To keep my life simple for now, the component will only handle scale effects, meaning I want our main character to pop slightly larger when collecting coins. Simple to implement, but it completely transforms game feel. Okay, I have this right now, and I hate it. The component has internal variables, states, and loads. I'm not thinking about the future, so delete. Imagine down the road when this component needs to handle particles, sounds, animations, and camera shakes all at once. It's too much. I want it to manage effects without needing to know how those effects actually works under the hood. I know, it sounds weird. It's like buying a brand new washing machine. Years go by and you still have no idea what dry cycle 6 actually does. So I spent some time thinking. Hard to believe, I know. And I decided to build effects modules. Basically organized drawers for our effects. The component will hold specialized modules, one for audio, one for particles, one for camera effects, and whatever. That way we can just shout trigger the pickup, and the component simply passes data to its modules. A single pickup event can scale Chester up, burst a particle, and play a sound. The component doesn't care how the audio plays, it just tells the audio module to do its job. I hope that makes sense and isn't as confusing as dry cleaning. How do you even wash something dry? With powder. This is the cleanest extractor I could find. Now we can stack as many modules as we need. We solve a major issue, but now we have an even bigger one. Will it compile? Well, apparently not. After staring at it for a bit, it, I found the culprit, a circular dependency. That's when file A depends on file B, but file B also depends on file A. In short, they're codependent on each other. Classic design flaw, but after banging my head against the desk for a couple of hours, it fixed. As you can see, the component exists and Chester reacts to the coins, but the component isn't actually doing anything yet. What you're seeing is the old code I forgot to remove. Out with the old, in with the component. Let's head back to the engine and see if it's scaled properly. Nothing happens. Right, we need to configure the component first, and this part is amazing, I promise. Really, I promise. We click here, on all our keys pop up. We select pickup. Below, we see scale, our scale module. We tweak the settings and we are good to go. It supports curves, but let's test with a flat 1.2 scale. Thank goodness it works. Over on the coin side, I added the exact same component, but the coin shouldn't scale. It needs to spawn a particle. That's the catch. Right now, our use component only handles scaling. Our next objective is building the particle module. The beauty of this architecture is how scalable it is. I just create the module, set up its configuration, and that's it. Moment of truth. Let's see if it compiles. It compiled. Let's open the coin blueprint, configure the particle, and test it out. It's spawning 2 particles because the old hard-coded logic is still running. It's always good practice to refactor and verify everything works before deleting legacy code. Now that we know it works, goodbye all logic. Do you see how awesome this is? The character and the coin both respond to the exact same key, pickup, but one scale up while the other pops a particle. Same event, different configuration. Small technical wins like this makes me absolutely happy. Plus, we can insulate and debug effects instantly. If a particle effects obscure the scaling animation, we just toggle the particle module off. No code changes, nothing broken. I could sit here and build out 5 other modules on camera, but it would just be repeating the same steps and get it boring fast. I think we tackled our goals with flying colors. We went from messy logic scattered across the entire project to a clean Lego bucket ready to trigger game use in 2 clicks. The system is scalable, clean, and easily testable. I think we finally figured out what Dry Cycle 6 does. Thanks a lot for sticking around until the end of this video. I will see you in the next one. Bye.